This is a video lesson for day 5 of our decimals unit. The day 5 learning target is I can use understanding of fraction equivalence to investigate decimal numbers on the place value chart expressed in different units. So today's lesson is going to be all about looking at decimal numbers using different units. So looking at them in terms of tenths or in terms of hundredths or just as a mixed number or decimal. So let's go ahead and jump into the first problem so I can show you what I mean. So this first problem here is going to be expressing decimals in different units using an area model. So I'm going to be using the example of 2 ones and 4 tenths. And I'm going to start out by just representing that as a decimal. And I'm using the area model. I'm going to fill in my 2 holes. So each of these squares is equal to 1 hole. So there's 1 hole filled in. There's 2 holes filled in, and then I have 4 tenths on my third area model here. And so what I've done is I have gotten 1 hole plus 1 hole plus 4 tenths. And so this equals 2 and 4 tenths, or as a decimal, 2.4, 2 and 4 tenths. So that's just reading it as a decimal, but we can also look at this number in terms of tenths. So if I were to look at how many tenths were in this area model right here and this area model right here, I could see that there are 10 tenths in the first square and 10 tenths in the second square. And then there are 4 tenths in the third square. And so if I were to represent this number 2.4 or 2 and 4 tenths in terms of tenths, I could also say that this is 10 plus 10 plus 4 tenths, which is 24 tenths. So right now we have 2 different ways to represent this number, 2 and 4 tenths or 24 tenths, and they're both representing the same value. But I can even go one step further and represent this number in terms of hundredths. So I'm going to go ahead and partition each of these area models here. I'm going to try to do it as quickly as possible. So I'm partitioning these into hundredths now. So there's the first hole partitioned into hundredths. And I'm not being 100% accurate. I'm doing my best to make sure my lines... Let's see, yep. Got my partitioning it at 10 horizontally. And to split these tenths into hundredths. So there you have it. I've split all of those into hundredths. And so if you think about this area model right here, this square in terms of hundredths, we now have 100 hundredths. Same thing with the second one. We have 100 hundredths. And then right here we have 40 hundredths because each one of these little rows right here, or these columns, has 10 hundredths in it. So we have 40 hundredths. And so this gives us 100 plus 100 plus 40, which is 240 hundredths. So you can see that we just added a 0 onto our previous amount of tenths, and that gave us the number of hundredths that this number represents. So that's 3 different ways with using 3 different units that we can represent this number. We can represent it as a decimal or a mixed number in terms of tenths and in terms of hundredths. So that's all using the area model. We can also use another strategy to represent different numbers with different units. So I'm going to now be expressing decimals in different units using a place value chart. So let's go ahead and zoom in and start with this first problem right here. I'm going to be representing 3 ones in terms of tenths using the place value chart. So I'm going to start out by representing this number on the place value chart with just little place value discs. So 3 little dots in the ones column. And then when I think about the ones in terms of tenths, I know that 1 whole is equal to 10 tenths. So each of these dots right here, I can unpack into 10 tenths. So there's the first one. There's the second one. And there's the third one. And so that gives me 10, 20, 30 tenths. So 3 ones in this case is equal to 30 tenths. And I did that by unpacking each of the ones and knowing that 10 tenths was going to equal 1 whole or 1 one. And that gave me 30 tenths as my answer. And so we could do the same thing when we're working with a mixed number as well. So in this case we have 3 tenths. So this isn't necessarily a mixed number, but a mix of two different units. 3 tenths and 3 hundredths. And using our understanding of fraction equivalence, we know that 1 tenth is also equal to 10 hundredths. So I can actually unpack each one of these tenths into hundredths, unpack them into 10 hundredths. So there's the first tenth unpacked into hundredths. There's the second. And there's the third. So I have 10, 20, 30 hundredths plus the 3 I had up above. So that gives me 33 hundredths. And you might have noticed that those are actually the digits that we had in our original problem. So this 3 kind of became the tens place, and this 3 kind of became the hundredths place. So 3 tenths and 3 hundredths is actually equal to, we can also represent that as 33 hundredths. So once again, it's all about just looking at these numbers a different way, being able to represent them with different units. So with that in mind, we can actually go ahead and take the next step and start to represent, this is like the final step here, I guess, of being able to represent any number in terms of different units. So starting out here, we have the example of 4 and 1/10 being represented as a decimal. And then that 1/10, or this 0.1, is represented as a mixed number here with 4 wholes and 1/10. So as it's represented in a mixed number, it's then transitioned into be representing in tenths. So in this case, what they did is they took the 4 tenths, or the 4 wholes, and they represented that in tenths. So 4 wholes would be 40 tenths, plus the 1/10 would be 41 tenths, which is what they got. And they represented that in unit form and as a fraction. And then the trick to representing the same number in hundredths is we're going to be multiplying the value by 10, so the number of them by 10, and the value is going to be divided by 10. So 1/100th is 10 times smaller than 1/10, but we're going to have 10 times more of them. So you notice that there's the 0 added on to the end of 41 because we multiplied the number of hundredths by 10 because hundredths are 10 times smaller. And then also with our fraction, we have a 0 added on to the hundredths and the 0 added on to the numerator and denominator. So that's how we go about transitioning from tenths to hundredths. So let's see if we can do this example here of 5 and 3/10. So I'm going to start by representing it as a mixed number, 5 wholes and 3/10 written as a fraction. So now to transition this into tenths, I'm going to think about how many tenths does 5 wholes equal. And I can just skip count by 10 5 times. So I can go 10, 20, 30, 40, 50. So 5 wholes is going to be equal to 50 tenths plus the 3 is going to be 53 tenths, which I can write as 53 over 10. And then to transition into hundredths, I know I'm going to be multiplying the number of tenths by 10, so that's going to be like adding a 0 on the end. And that gives me the amount of hundredths. And then that becomes my numerator, and my denominator is now hundredths. So there you have 3 different ways that we can represent this number, actually 4 different ways, as a decimal, as a mixed number, in terms of tenths, and in terms of hundredths. So at this point you should be able to handle any of the questions in the day 5 problem set. But if you get stuck or need a refresher on any of the concepts, feel free to come back and rewatch any parts of the video that you need to. So good luck with the problem set, and thanks for watching.